Hi everyone, welcome to Code and Chill. As usual, let's try to solve one of the questions in LeetCode 75. The goal here is not to find a solution and be done with it, but rather try to learn something new. If we have forgotten something, let us go ahead and refresh our memories and so on. So let's try to have some fun while we are solving this problem. So we have done a few in array and string. We have not done any in two pointers. What else do we have? Let's see, what should we choose today? How about a linked list? We did a binary search tree problem, so doing a linked list should be something simpler now, right? Who knows, we might solve 2 or 3 questions today instead of just one. Yeah, let's see how it goes. So this is in C++. Let's go to Java and see how it looks like. Maybe JavaScript. So since we did the binary search tree using Java, let's start with Java and then let's move on to maybe JavaScript today. Okay. So first of all, what do we need to know about a linked list data structure? Let's quickly ask ChatGPT to help us refresh our memory. Give me main aspects of linked. Give me, I don't know, give me, yeah, let's forget the English. It will be able to figure it out. Okay. Awesome. Thank you for this. So the structure of a linked list is that each, the smallest component of a linked list is called as a node. Each node has data or the value stored in that, and a pointer is a reference to the next node. So there are different types. So the first one is a singly linked list where each node points to the next. Let us draw this to make it easier for us. So let's say this is a node and it has 2 components to it. So the first component is the value. So I think I should start it somewhere at the top so that it is clear. So I'll just choose this again. Yep. So value or val. And then the second component is the reference to the, okay, let's make it better. Sorry about that. Let's see if I can choose this and, yeah, and a reference to the next node if it is present. So let's create, this is the reference. It is saying the address of the next node. So consider that this is a house, right, in street number 1, and then you go there, you find another node where the address of this home is written. So that's what this is doing here. So you know, like you're doing a scavenger hunt or treasure hunt or something like that. You get one clue and then move on to the next clue and so on till you get to the end. Right, so there is value again in this linked node. Probably this is the last one. So you have reached the destination. So it does not have reference to anything else. So you know this is the end. So that's why it's a null. Just to show the direction and also add arrow mark. This is a very simple linked list. The node the first node which you have in the linked list is called as a head. Oh my God, I need to use an eraser. I'm sorry. And then let's say this is the, let's make it extra large and say this is head node. And this one is called as the tail, I think. Okay, that's at least what I remember. And what else? So a doubly linked list would be where there are two references. So you go to this house or this node, and then you also have a reference to the other node. So let me also quickly draw that. So there are one value and two references. So you have the reference to the node before it. Since there are no node, it will be null. And then you have the value, and then you have the ref to the next node. So this is the head node because there are no nodes before this. And then let's create a tail node. Of course, you can have multiple nodes in between, but for simplicity's sake, let's just have two nodes. Right? What is important is we understand the concept. We can increase the complexity at any point of time. Right? So this is the value, and then this will now have a reference to the head node. Okay, I didn't choose the right one. So, wow, here are the pointers. So ref to the head node, I would say, and then I need to increase this to accommodate for my, you know what I'll do is just say this is the reference to this, and this will be again null because there are no nodes after that, and this will be a reference to this. Right, so this is doubly linked list, linked from two directions. The advantage of doubly linked list is you can go this way as well as this way. And then the circular linked list, that too makes sense, where the last node will have reference back to the first node. I should use this, and then now it is, so this will refer back to this node. So that becomes circular. Now the same thing can be done with the doubly linked list too, right? And this will have reference to this. Yeah, so those are some main things about linked list. So the basic operations are, we can insert a node, delete a node, traverse through the linked list, search for a specific value. So, well, one of the main disadvantages is that you see here in an array, if you have an array, you can, let's say you have an array and you have multiple values in that array. You can go to any part of this array by just using the index, right? I can go here, I can go here, but in a linked list, you have to go from, you have reference to only one head node. If it is, say, a single linked list, and then you keep on going till you find the value that you want. There is no direct access. And of course, we need to store the reference value, which will take extra space. But linked list, we can consider this as a disadvantage, but every data structure is there for a reason, right? You cannot say this is better than that. It depends on the application. So, yeah. So let's not judge linked lists, saying that they take more space than an array, right? They have their advantage. They are very powerful when it comes to some use cases. Probably we will find it soon. We also saw one example with the binary search tree, where we could implement that using linked lists only. We could not use arrays for that. Everything has its purpose now, doesn't it? Okay, philosophy aside, let's come back to the question. So what is the question here? So we have given the head of a singly linked list. Okay, we know what a singly linked list is now. From the head node, we just have access to the next node, so on till the tail. And we are given the head. That is good to know. Now we need to reverse the list. Oh, wow. So that is very interesting. Now we have access this way, but we need to change the access in the other direction. So if we look at a simpler example with just 2 nodes, we see that the thing, this has to be reversed. So let us look at that. And let me just use some comments to make my points and go through my thought process here. So when we have a linked list, right, in this diagram, what we don't see is the reference that it has. So let me first write it down. I'll just use 3 points now instead of 5 points because it is easy for me to write. So I will say that it has a value equal to 1 and next, which points to or is equal to ref of the second one, right? So it's the reference for 2. So that is the first linked list actually. So this does not say very clearly that there is also another additional information. So just to make it clear, right, using something like this notation, I will say this is the value and the next is the reference for 2. So I'm also referring to val and next here. Okay, so the next node we have is val equal to 2, and I think this is a better way to separate it out. Okay, and next equal to a reference to this one, the 3 linked list node with value 3. So the next node has value equal to 3, a reference equal to null. Why? Because I have chosen a linked list which looks like this. Okay, it's not the same example. This is the linked list. And this is my representation, or a more clearer representation of all the nodes. So this is the node 1, then this is the node 2, this is the node 3. So what do we need? Let's see that also. Expected output. I'll just copy this first. That's what all developers like to do, right? Copy paste. So, okay, let's see what the expected output is. I'll again copy this. It should be 3, 2, and 1. And so this will be 3. It will refer to 2. This is 2. It will refer to 1. This will be 1 and reference will be null. So now this is the input and this is the output. What changed between these two? We can just look at the values first. Well, the values reversed, right? The values got reversed. What happened to the reference? Interestingly, the reference remained same because, well, why? Because the address of this location has not changed. So, what if, so this gives us an idea. What if we can just reverse the values, right? That is one way of looking at it. Now let us just compare the references in a sense. Can I keep the nodes as is, but just make, so that is the first approach. In the second approach that we are thinking, approach 2, what if I just shift this arrow from here to here, here to here? Now this will again be same as this, right? So here we are reversing the references. We are not changing the node and its value, but just reversing the references. So approach 1, reverse the values. Approach 2 is reverse the references. So this looks pretty cool. So again, let us consider this as 3 different homes, right? I think the drawings are helpful. Maybe I'm wrong. Please let me know. So let's say there is a house 1. Let me try to do a proper house here. So this is house number 1. I think it will become clear when we draw houses, right? Yeah, let's see. So there is house 2, and then there is house 3. And let me quickly draw this. Yeah, pardon my drawings for sure. Now this house has a value 1. This house has a value 2, I'm sorry. And then this house has a value 3. And there is address of second house from here. So I'll just, let me see, how do I show that? Maybe this is good. So from house 1, you know the address to house 2. From house 2, you know the address to house 3. Okay. So now the first approach that I said here, right, is to reverse the values. So how do I select and copy? Let's see. I'm going to copy this and paste. See, I love copy and paste. Okay, so what I'll remove the values. I will not change the address. Okay, I'll not change these arrows in the approach 1. Reverse, okay. Reverse the values. So let's not change the arrow marks, but what we will do is, we will say this is 1, this is 2, and this is 3. We will completely change the value. So now we have reversed the linked list. Now the second approach, how did that happen? Okay, let me copy this again, copy, and then I'll paste it. What? Okay, so I'll copy this, copy, paste, good. So now, what is happening here? Again, I will not change the house or the values, but I will just reverse this. I will reverse this. So this is the second approach where we are reverse the reference. See, these are 2 different things, but they are doing this. The final result is the same, but what we are going to do will be different. So let's try to do both and see how the code looks like. Okay. So let me ask ChatGPT to do this. Or first let me write the pseudocode. That should be good. So approach 1. Create a new linked list node, and how do we do this? So basically 1 and 2 is what we have initially, right? We just have the head, and from the head we can go to the next one. Since we want to completely reverse, we need to go till the end, right? So let's say traverse to the end of the linked list. Well, there's something more interesting coming up. Yeah, maybe some of you already got it. If not, we will see what it is, right? Another programmatic design is going to show up here. So let's travel to the end of the linked list, and then we found 3. Now create a new linked list node which has the value of the last node. right? And then you want to say that, so we have got 3. So what did we do? We came to this. And then we need the reference to 2. Where is the reference to 2? It was there in the previous node, right? So the previous node is something. So when you traverse to the end of the linked list, also have the previous node value, previous node stored. Now create a new linked list which has the value of the last node. So 3. Now add the reference from the previous node to the new node. So this is what we did till now. Now we need to create a new node. And what will its value be? So create a new node. It will have the value of the node, which is the current node. Let me write it down, right, to show what I'm saying. So create a new node. Make the previous node as the current node. This so when we go to the end of linked list, this will be the current node. Make the previous node as the current node, and then assign the value of the current node to new node, and then to assign the value of the previous node of the, assign the reference of the previous node of the current node to the new node. So when you go on writing like this, there is some pattern that emerges. So let me just go through it again. So that might help with understanding what this new pattern is, right? So when we go to the end, we need to know what is this node and what is this node, so that we can create these two things. And then when we want to create this one, we need to know about these two. Then we want to create this one, we need to know about this and its previous one. So basically, once we go forward, we want to move backward one step at a time. This is nothing but recursion. So this pattern is recursion. And there are 2 ways of implementing this. And let us ask ChatGPT to do this. So let me say, I'll copy this and go to ChatGPT and say, oops, I wanted to say something else. So let me go and edit it again. Wow, can't edit it? Okay. No issues. Let me say, reverse a linked list with the approach defined below. Oops, I didn't define. Okay. Awesome. Yep. Wow, I also wanted to ask it in JavaScript. So for now, I can say Java. So also provide this in Java. Still logged out. Blah, 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 blah. So what is it doing? So reverse list recursively. Where is that? This is the method what does it do? First, so these are all, like this is where we reach the end, right? This is what we are doing initially. We are going from the first node to the next node. Okay, then that is the same call as this. Again, we go to the next node from here. We come back here. Now, again, we go to the next node and then we reach this condition. So if we reach that condition, we go back. We say that is the new node and we have the reference of the previous node. So if it is not clear, let me paste this and then explain to you. The reason why I'm repeating the same thing multiple times is to make sure that you intuitively get an understanding of recursion. Sometimes recursion is considered to be some magic, but it is not. The pattern that you have to observe with recursion is when you're writing in plain English, right? What you see is you have to go to the end to do something, and then you have to take one step at a time backwards, one step at a time backwards. So when you do that, at the end of it, when you take all the steps backwards, you are done with the recursion and you have the final answer. So there is a way of looking at this. I think what I need to do is first paste it as a, sorry about that, public reverse whatever. I'll copy paste again. So what I'm going to do is copy this, paste it here and say this is the list head, and then you're going to return the list. Okay. So I wrote something here. I want to repeat it using this recursive call. So for the recursive call, what you need to see is the pattern would be, let's say, return value, recursive method, some input value, right? Call the same method. That's what you will see, call the same method. So basically what you will see is this. So once this method is called, you have access to the input value. And when you go one step inside it, you have access to the previous value also, right? So you keep on going one inside the other, one inside the other. And at the end, you say stopping condition. And this is the going forward condition, stopping condition, or you would say, yeah, that's the last stopping condition. This is the going backward logic. So from this is how we can translate here. So the going forward condition was, what did we do? Traverse to the end of the linked list. So to go to the end of the linked list, what do we do? From this node, we do the recursive call to this node. We then call this node. So we have gone to the end of the linked list. How do we know we reach the end? That is the stopping condition. That is where we know, okay, there is no more node. Or if it is the last but one, we say, okay, we have reached the tail node or the node which has null reference. That is the stopping condition. And then what do we do now? Once we stop, now we take reverse backwards. So we just take one step back. What do we do when we take that one step back? This is what we do. The going backward logic, as I call it. So this is what we are doing. So we create a new node. What do? We create a new node. And then what do? We add the reference, we add the value, and then we say we are done with it. So I hope this was a very interesting problem, though it was easy, right? What did we come to know? We came to know a lot of things about linked list, we came to know that the reverse operation can be done with two approaches. And then we did the first approach. And while doing the first approach or implementing the first approach, we came across recursion, right? And this is what we are doing in recursion. And this is how we are going to write in plain English about recursion. So there were a lot of concepts that we went through, and I think this is a lot for one day. Let us continue with the approach 2 and see what else we can learn. Thank you so much for joining me today. Hope you will join me for the next session. Have fun. Thank you.